Okay, so I'll make a quick little recording here of reaction mechanisms. Just if you're having any trouble understanding, you can follow along in your notes with this. So basically, a reaction mechanism is just breaking down a reaction into a series of steps, because it's quite unusual for the reactants to all come together in collisions all at the same time and to form the products. Usually these collisions happen in steps in order to get from reactants to products. So when you see the final balanced chemical equation, it only tells you which chemicals are present at the beginning, the reactants, and the end, the products of a chemical reaction. Really though, most reactions have a series of steps. Oops. What did I do here? And the steps produce things called intermediate products. So these are just chemicals that are formed throughout the reaction as a way to get from the reactants to products, but they don't actually appear in the final net equation or the balanced chemical equation. So the only way we can determine these steps, this reaction mechanism, is through experiments. You would not know what the intermediate products would be unless you were told, and they can only be discovered through experimentation. So a reaction mechanism is a series of steps which leads from reactants to products, and each step is called an elementary step. So let's just look at some examples to figure this out. So here's a reaction. 2NO, 2 nitrogen monoxide plus fluorine gas produces 2NOF. So that's your final net equation, your balanced chemical equation. But this reaction doesn't just happen all at once. It is broken down into 2 steps. So through experimentation, this intermediate product was detected, okay, and it's NOF2. So you can see if you look at the equation, there's no NOF2 appearing anywhere. However, it was temporarily part of this reaction. So it was produced at one point, but then it was consumed later in order to get to the final result. So when you see in a reaction that something is produced that's not part of the final balanced equation, that's an indication that the reaction is happening in a series of steps. So these are your steps. First step is the nitrogen monoxide. So your 2 reactants are added together. And then you can see that this is where the intermediate product shows up. Okay, so it shows up as a product here. And then you can see in the very next step, it is a reactant that gets consumed in order to produce the final product. Okay, so NOF2 is produced in the first step and used up in the second step. So it doesn't actually appear in the general equation, which I've been referring to as the net equation or the balanced chemical equation. So when chemicals are produced in one step and consumed in a later step, those are called intermediate products. So let's just rewrite out these steps, and then I'll show you how to come up with the general equation. So in our first step, we said NO plus F2. So those are our 2 reactants, but they don't instantly go to the product. They go to this intermediate here. And then in step 2, the intermediate combines with NO again to finally get to the product. Now you'll notice that each step is balanced, and that's important, right? So we have 1 N on both sides, 1 O on both sides, and 2 Fs in the first step. And in the second step, you'll see 2 N's on both sides, 2 O's, and 2 F's. So each elementary step is balanced. To get to your final general equation or net equation, you need to cancel your intermediates and also sometimes catalysts, which will appear in a later example. So this is an intermediate, and we know that because it appears as a product. So it's on the product side, and then it's on the reactant side. So whenever you see something appearing on a product side and then in a later step a reactant side or vice versa, that you can cancel that out because it's been produced but now consumed. So it's not there anymore. So then you just write what's remaining. So you have to count up. We have 2 NOs. So I'm going to put 2 NO, just 1 F2. And then we've got 2 NOF. So that should match the original balanced equation we started with. So this just talks a little bit about rates, which you've already learned about. But it just says reaction mechanisms show why the rate of a chemical reaction has to be by experiments. So what this means is when you're doing your rate laws, when you're figuring out the rate laws and it's a multi-step reaction, so more than just one step, you can't just figure out the rate law of multi-step reactions by looking at the balanced chemical equation. You actually have to do trials and play around with the concentrations of your reactants and see how that affects the rates. So these reaction mechanisms actually get tied in later into the rate law stuff. The only time you can find the rate law from the balanced equation is if it's a one-step reaction. And one-step reactions are a lot less common. Generally, all these steps have to take place before the reaction comes to completion. So here's another example, and this one involves 3 steps, and it has both intermediates and catalysts. So I'll show you how to tell the difference between the two. So first, we're just going to look and see what appears on both sides in our steps. So right away, we can see this ClO is here, a product, and then later in another step, it's a reactant. So when it's a product first and then a reactant later, that's an intermediate. So there's one other intermediate. Okay, you'll notice here, product first, reactant later. Okay, so both ClO and O are intermediates. And the reason we can identify them as that is because they appear as products first. Okay, now you'll also see Cl2 appears here and here. So it also needs to be canceled out. The difference with Cl2 is it appears as a reactant first and then a product. So that indicates that Cl2 is a catalyst. And the reason we know that is because a catalyst gets added to a reaction to speed it up. So you add it in with your reactants to make the reaction go faster. So we know it's a catalyst because it appears as a reactant first. Okay, so everything is canceled. So we rewrite our equation. We've got 2 O3s and 1, 2, 3 O2s. Okay, so if all your steps are balanced, your net reaction should also be balanced, which it is. Now this says propose a 2-step reaction mechanism for this reaction. So it's the same reaction, but how could it be done in 2 steps if O is the intermediate product? So that means ClO is no longer going to be an intermediate. If we're just going to do it in 2 steps, there's one intermediate and there's no mention of a catalyst. Okay, so this takes a little bit of thinking. So what you have to do is you always have to start with your reactant. So I'm just going to start with one of these ozones because I know I'm doing 2 steps, so I'm likely going to use one ozone molecule in one step and the other one in the second step. Okay, so this, if I know I need this intermediate O and there's only 2 steps, it has to appear as a product in step 1 and a reactant in step 2. Okay, so I know I need O appearing as a product and I need this to balance. So that means I'm also going to produce an O2 here. Okay, so I've got an O because I have to have it. It's telling me it's an intermediate. And then to make it balance, I've also got an O2. And you also have to think about the fact that in the end, we need a total of 3 oxygens. Okay, so one of them is going to appear here in the first step, which means we're going to need 2 of them to appear in the second step. So in step 2, I want my intermediate to be a reactant because I need to get rid of it. It's only there temporarily. Okay, so if I have it as a reactant, then my other reactant is going to, the only other possibility is O3. I know I need a total of 2 of them. So here's my second one. Okay, and this on the reactant side gives me a total of 4 oxygen atoms. So it would make sense then to make 4 on this side. And that will also add up to 1, 2, 3 oxygen molecules total. So I can see then that O will cancel. And I'm just going to write the net over here. 2 O3s produces 3 O2s. So that's a little trickier to come up with the steps yourself. Generally with reaction mechanisms, you'll be given the steps and you just have to identify if there's a catalyst or intermediates and do the canceling and come up with the net. Okay, so last little bit here, the rate determining step. Basically, when you have a series of steps, they each happen at their own rate. Okay, but the overall reaction rate is determined by the slowest step, and the slowest step is called the rate determining step. Which is sometimes shortened to RDS. And the overall rate of reaction depends on the rates of the step, but you get that overall rate from the slowest step. So that's what has the greatest effect on the reaction rate, I should say. So basically a chemical reaction can't go any faster than the slowest step, which is the rate determining step. So that's what's going to tell you how fast or slow the reaction takes place. So let's just do 2 more examples here where we come up with our net equation and what our intermediates are. In terms of the rate determining step, once you get into rate laws and you're figuring out the rate law, you'll be told, you know, usually it'll say beside one of the steps slow. And that tells you that that's the rate determining step, and that will have an effect on what your rate law is. Okay, so your rate law comes from the slowest step, the rate determining step. So let's cancel out. We've got an X here, a product, and then a reactant. So we know that's an intermediate. And we've got Y as a product and then a reactant. So that is also an intermediate. So if we write our net equation, we've got 2A plus 2B produces 2C plus D. and our intermediates in this case there's two, are X and Y. Okay, last example, we've got two steps in this reaction mechanism. So if you look through everything, you can see NOCl2 appears as a product first and then as a reactant. So that's our intermediate. The net equation 2NO plus Cl2 produces 2NOCl. And we can just write that the intermediate is NOCl2.